All right, now it is time to go over bubble sort. Of course, before we really get into that, um, we need to get a few things built prior to that. So for our project, and you can go ahead and make one, for this project we're going to need a couple of things. First, we're going to want a method that will fill my array. Now I've got it set to fill a random number, and I've got it set to basically just take the array and take the number that I want, the maximum number I want allowed. So if I want, random numbers between 0 and 10, I pass it a 10. Or I guess 11 in this case. If I wanted to adjust it a little bit. Because 10 would be me 0 to 9. If I wanted it to be, actually be, I guess, 0 to 10, then I would just add 1 to the end of that max. But this will at least give us an approximation. It doesn't have to be perfect. If I wanted it to be 1,000, then I'd pass it 1,000. And all this is going to do is fill the array I gave with random numbers. So that's the first thing we need. The next thing is just to be able to print. We want to be able to see that it's doing what we want it, we think it should be doing. We're not going to use this all the time, especially when we get to the larger sizes of the arrays. We'll start with 10 numbers, for example, and we'll see if our sorting algorithm we're going to go over actually is working. If it is, then we can mute the print and we can up the size of the array and see how long it takes to do certain things. Now before we get into the actual bubble sort, we need one more thing, and that is a timer. Now I need to know how long it took for this to actually do its thing. So I've got this system current time millis that gets the current time of the system clock. I run my algorithm, and then I do this again. And that's the end time. And I do a little simple math to figure out how many milliseconds pass between those 2 points of time. So effectively, it's going to tell me, how many milliseconds it took. A millisecond is 1,000th of a second. If anyone's ever played any games online, your ping is usually registered in milliseconds. If you have, anywhere from 20 to 200 ping, you're probably okay to play most games for the most part. Once you get up to 500 to 1,000, 3,000, 4,000, ridiculous numbers like that, that means there's like a 4-second lag between what you're doing and the game registering it, which anyone who's ever played any games probably notices that that is infuriating. It's horrendous to click and be like, go get that guy, and then to watch your person stand there for 3 seconds before they do it. And then you're getting attacked and you're like, run away, and they stand there for 3 seconds before they start running away. Yeah, lag in your ping just is terrible. And it's kind of an interesting way to measure that. So now, this is the main. You see I've got an array just with 10 items. I'm filling it with like 0 to 99s. I have my start, which is it's a very long number. How many milliseconds between these two if you want to print it out just to see. I run the bubble sort, which we're going to get to in a second. And then I get the end time. And we're going to print the first time we do this just to see that it's actually sorting. And then I'll comment it out. And then we'll just print off the time, how long it took for that bubble sort to run. So, without further ado, let's get to the actual bubble sort. Now, bubble sort is one of the simplest sorts. I like to break sorts up into whether they're recursive or whether they're loop sorts, is kind of the phrasing I use. Insertion, selection, and bubble are all loop sorts. Oddly enough, shell sort is actually a loop sort, but it's a completely different animal than these others. Merge, quick, and I guess heap and other quicks are all recursive sorts. for the most part. So recursion is when a method calls itself over and over again. We'll get further into that later. But for now, we're just looking at bubble. Now you can see the sorting for bubble is basically two loops. We see which one's smaller and we swap them. That's it. And we take a quick look. You'll notice that the smallest number gets swapped up all the way until we get to the top. We just keep swapping, swapping until it's sorted. Doop. So it's kind of like the small number rides this bubble all the way up to where it's supposed to be. So we go through here and we just keep sorting it until we find the number that needs to go up, and we bump it up, bump it up, bump it up. Now you can see in small cases, this doesn't take that long, really. But if I were to, bump up the numbers, the size, that's when it gets really, really slow. Bubble sort is one of the slower sorts. Insertion, selection can be slower, depends on the particular thing. I think actually I have found selection usually to be the slowest, but it depends, like I said, that none of them are going to be fast. So let's just reset that. Okay, so let's take a look at the sort. So bubble sort itself is this. I've got a temp. I set it to 0 at the start. I have two for loops for I, the array.length. And it starts at 0. And then notice the second for loop's got a slightly different structure. It starts at 1, and I go while j is less than the length minus I, and then I increase j plus plus. And basically what this is going to do is it's just going to go down the list and compare. Is one bigger? I swap the number to a temp. Basically what these three numbers are doing is juggling. I move the value I want to move up into the temp. I copy the value over into the old slot, and then I move the temp value back into the new slot. So think of it like juggling three balls. I juggle one up, I toss the other to this hand, I throw this one over this hand, grab it. I can only hold two at a time. So basically what I'm doing is juggling these variables. So that's it. Pretty simple, straightforward. Two for loops. And we go through the entire thing, moving the small one up until it gets to its position, moving the next one up, moving the next one, next one. And we're just going to keep doing this until we get them all sorted. So let's take a look and see how this works. I'm going to go to my main. I've got my array declared as 10 for now, my fill as 100, and I got my milliseconds, my timer. Now I'm going to print it so we can actually see that it sorts. Now it's going to fill with random numbers. So we'll run, and there we go. Array 0. I would say that's pretty sorted. The time is 0. It took no time at all. It can't even register the time for the most part because it took literally no time to sort this. I hit it again. It's short. If I come up here and it is sorting from the looks of things, so I can just take off my print for now. You can leave yours on if you want. I'll go ahead and add in an extra 0. Now I got 100 things to sort. Let's take a look. Still took 0 time. All right, let's go to 1,000 things. 3 milliseconds. Remember, this is in milliseconds, so milliseconds. All right, we'll go to 10,000 now. And this is where you're going to notice a remarkable difference. 120 milliseconds. See, it skyrocketed. 100,000. Bum, 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 bum. Now, note it went from 3 milliseconds to 120, and now it's 12,000. which is 12 seconds, if you compare the two. So it went up, what, 100 times, basically. Now, if I were to go and try a million, which we're not going to do that because I don't want to sit here for, like several minutes, it would take even longer. So the one issue with bubble sort is the longer it goes on, the longer it takes to, sort. There are other algorithms that would sort a million items in like a couple of milliseconds. And keep in mind, they're just doing the exact same thing. They're sorting, it's just the algorithm itself is not really well designed for large things. Now, if I just wanted something simple that sorted like a small little thing, small little array of 100 or so people, or 100 or so things or items, this would be simple, easy. Just, write a couple of these lines, bam, there it is. Of course, there is built-in sorting into Java that you can use, and it is always going to be more advisable to use built-in stuff than it is to just make your own stuff. Always. Because the built-in stuff works, whereas the, you know, stuff that you're writing yourself, there could be an error. Maybe you forgot to carry a 1 or move something over. Uh, Something along the lines of that. Built-in stuff will not break, whereas your stuff could. But to know how this works, we still have to look under the hood and know how it comes together. All right, well, that is bubble sort. Hopefully, you look forward to the next sort or two in the next one.